Recording.
We're studying the train brake design systems, past, present, and future. This is Christopher Pinto, myself, Ruth, Quant, and Andres Gomez.
Train brake history began in the 1820s with a simple brake design. It was a simple lever that was pushed and the brakes were activated. It wasn't very good, so they designed 4 solutions, which was the chain brakes, hydraulic brakes, simple backing, and automatic backing. The chain brakes were just a long chain along the train and activated by hand. It was useless due to the length of the trains. So they came up with the hydraulic brakes, which is pressurized a fluid, but their major design flaw was that the fluid was water, so it will freeze during winter. So they came up with the simple vacuum brakes, which is an injector pump that vacuums air and then opposite pressure just activates the cylinder, and it was not operational when there was a leak. So they came up with the automatic brakes, which is the same as the simple brakes, but each system was separated per cart, and it was really expensive. This is where George Westinghouse came in, and he patented the idea of air brakes in 1860. By 1869, he had a working unit. And by 1870, all passenger trains had this system. By 1930, all trains, the standard was air brakes.
Currently, there is the air brake system in play. There's the simple air brake, which is the Westinghouse model, and the automatic air brakes. This is a basic air brake system where there is a main reservoir that pumps air pressure from the compressor and travels through the brake line through each system. These automatic air brakes travel throughout the length of the train, giving it a domino effect when the driver or conductor presses the brake. The brake pressure is released from the brake cylinder to push the brake block onto the wheel and stop each wheel. However, currently, to enhance that pneumatic system, there's electronically controlled pneumatic systems, keeping the same idea of the air pressure. However, each cart now has an electro valve along with electronic wire throughout the length of the train, so that when the conductor presses the signal from the first cart, there's an electronic signal that creates almost a simultaneous braking system throughout the length of the train, which decreases stopping time and stopping distance. And each braking system has a fail-safe system, which means that the brakes are maintained in an off position, but when there is a decrease in pressure or release from a broken brake pipe, all the emergency vents in each car releases the air to atmospheric pressure, creating an emergency stop.
The future of train brakes lies in regenerative braking and eddy current braking. The regenerative braking is already pretty standard in all of the newer trains, and the eddy current is used in most of the high-speed trains. So regenerative braking, the way it works is basically in an electric motor, you input current and get out kinetic energy. In this place, they switch it, and they switch the current, so it takes the kinetic energy and transforms it into usable electric energy. And the problem with this is that it can be used with DC current, but it's very efficient with AC. Eddy current brakes, so these are the ones that are used with high-speed trains. In the case of there's 2 circular eddy brakes and linear eddy brakes, and the configuration for them, you can be used with electromagnets or regular magnets, and with the electromagnet you can vary the intensity of the braking. So the circular brakes, the way they work is there's a magnet that creates a field between the rotor and the rotating coil, which creates a resistance opposing the motion. And the energy is dissipated as heat into the rotor. And with linear brakes, it's a magnetic yoke with electrical coils in the rails. And basically, it creates a magnetic field that causes a magnetic force that opposes the motion of the train. So it's basically being pulled back instead of the motion of the wheels being opposed. And the energy is dissipated as heat into the rails. And the main problem with it is that with existing tracks, you have to change the covers of a lot of things that are magnetic and will get pulled out because of the electric field.